Variable length subnet masks. This presentation provides a very general overview of variable length subnet masks. It is assumed you already have a firm understanding of how to subnet, and a brief review of subnetting is provided along with some of the common terminology associated with variable length subnet masks, or VLSM. The terms you see here are positioned throughout the course of this presentation. Organizations are creating their networks. They acquire IP addresses in blocks. For example, 192.168.40.0 will be used as a model for the rest of this presentation. This gives them a few choices in how they want to plan and use the IP addresses they acquired. They can create one giant network or break it into smaller ones through subnetting. The 192.168.40.0 referenced could be considered classful. This means the network boundary is predefined based on the open octet, the 0. The higher order bits in each octet are subsequently put into class designated by an alphabetical letter, A through E. A class A would be 0.0.0.0 to 127.0.0.0. The subnet mask would subsequently follow, depending on which bit is being used, an increment by the number associated with the value for that bit: 128, 192, 224, 240, 248, 252, and 254. The 255 in the first octet is predefined. A Class B address would be 128.all0s through 191.all0s. Since you would be working in the second octet, that would also have a value in the subnet mask of 255, an increment in the third octet. A Class C would range from 192 to 223, Class D 224 to 239. This class is reserved for multicast, and a Class E is reserved for future use and ranges from 240 to 255. In this example, 192.168.40.0 with a subnet mask of /24 255.255.255.0 has a possibility of 256 addresses. In this example, we have a headquarters, which is designated by a router, with several extensions, and each extension is using only one address out of 256 for a total usage of only 8 addresses. This creates a lot of waste. A better way to do this would be to borrow some of the bits from the last octet, create the networks that are needed, in this case 5, which would limit the number of IP addresses that can be assigned on each local area network. 30 total. VLSM is basically a way to maximize your addressing scheme within that same block of addresses that we were previously using, except the subnet masks don't have to match. The IP addressing in the subnet mask will be determined by the number of hosts you will actually need for each network. This provides more flexibility with IP addresses, diminishes IP address waste, and removes the classical subnetting scheme, provides overhead of routing processes, table population and maintenance, as well as routing distribution. It is supported by several routing protocols: RIP version 2, EIGRP, OSPF, ISIS, and BGP. Because of the multi-subnet masks that are used, these are just determined to be classless addresses. Each IP address is processed as a 32-bit number represented of ones and zeros. The network portion of the IP address ends where the ones stop and the zeros start. It is designated with a slash notation, which represents the 255 portion of the subnet mask, and increments depending on where the ones stop and the zeros start. For example, 192.168.40.0 with a /24 mask of 255.255.255.0. In this example, we'll need 8 network addresses with 60 hosts on the HQ LAN 1 and 2, 30 hosts on the branch LAN 1, 14 hosts on the branch LAN 2, and provide 2 hosts for the link between the 2 routers. It will result in network 1, which would be HQ LAN 1, having 62 possible host addresses and starting with the 40.0. HQ LAN 2 has the same possibility, but would start with a 192.168.40.64. Branch LAN 1 only needs 30 hosts. It will start at .128. Branch LAN 2 only requires 14 hosts and will start at .160 and use a /28 mask, with the last being a /30 because we only need 2 host addresses for the WAN link between the HQ and the branch. The scenario that I just described is shown in this topology. Classless interdomain routing, pronounced CEDAR or CIDR, is a method of distinguishing the subnet mask of IP addresses with a slash notation. It is based on VLSM, but it also allows for backward progression of subnets to be combined into much larger supernets. This routing table actually shows that the slash notation where the IP address, the block originally 192.168.40.0, was subnetted to fit the IP addressing scheme. The subnet mask of /26, 27, 28, or 30 is also published with the IP address. The supernet is the process of combining a block of subnetwork addresses, into one larger address and provide more efficient routing. This keeps routing table entries down to a minimum and uses less processing time for the routers, as well as provides faster updating. In this example, 192.168.40.0/24 is a combination of all of the routes that were previously shown, as you can see in the next slide. 192.168.40.0 is entered into the table on the ISP S0/0/1 interface. Presents all of the networks that are possible to be reached exiting that interface. This presentation provided a general overview of the terminology used when discussing VLSM, reviewed basic subnetting, and discussed variable length subnetting and classless interdomain routing.